Okay, in this video we are going to take a look at the second half of lesson 4.1, which deals with some applications. Have your calculators ready because I am going to show you how to do these questions on your calculator. The first example is really is detail oriented. I show a lot of pictures and graphs. The next few examples don't show as much, so you may have to refer back to that first example to get the correct window and so forth. So let's take a look at what we're talking about. First of all, we're going to have a general template for any kind of growth or decay problem. And in this case, every variable stands for a different thing, as in most cases. So the first letter, which is in the color green, is your initial amount. So if you were talking money, you could say you started with $3,000. That would be what the value of A would be. The value of R is either your rate of increase or decrease. Notice you have that plus or minus there in the middle. If it was increase, it would be 1 plus R. If it's decrease, it's going to be 1 minus R. T stands for the number of time periods, and A of T stands for your final answer or your final amount. Basically what you're looking for. So let's take a look. Again, inside the parentheses we have either a 1 plus R or 1 minus R, depending on what the question asks you. So if you see the word increase, you're going to use the 1 plus R. If you see the word decrease, you will use the 1 minus R. Alright, here's an example. Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use a graph to find when the value of the guitar will be $60,000. Alright, so we have a few things here that we need to keep in mind. The year 2000, that it's increasing, and the rate is 14%, and we want to know when the value of the guitar will be $60,000, so that's the ending amount. So if we start with our little formula that I defined in the previous slide, the initial amount, A, is going to be $12,000. The rate of increase is 14%. We're going to change that to a decimal, 0.14. We don't know when, so T is really the variable that we're looking for. And the ending amount is 60,000. So the way that you're going to do this is, first of all, you'll notice that I have two numbers that are in black. And based on what I'm allowed to do with algebra, I can isolate the portion in red by simply dividing both sides by 12,000. This is going to bring the numbers down just a little bit, which will be very helpful. So when I take 60,000 divided by 12, I wind up with a number 5. And this really makes a somewhat complex equation into a very simple one. Now here's where your calculator comes in. You're going to enter the right and left sides into y1 and y2. The order doesn't matter. So looking at this picture, you can see that I put 1.14 to the x power in y1, and I put 5 into y2. Now if we hit zoom 6, what we're trying to find out is when will those two graphs intersect with each other. When will they be the same or equal? And you'll notice that the graph is kind of not in the window that I've created. So what I'm going to have to do is I'm going to have to adjust the window. I need more x max. So what I'm going to do is I'm just going to pull it out to 20. And I can shorten up that x min a little bit because we're speaking about an application, and the x value represents time, and time is not going to be negative. So I'm going to shorten it up to -2, even though that in and of itself is not practical. But if we make it 0, we won't be able to see the y-axis. So play around with it a little bit. It just takes a little bit of playing just so that you can get a good window. So once I have made that adjustment, you can now see that I'm looking for that point of intersection. And you can use the trace key. What you're trying to do is to see when they both equal 5. And so again, since your calculator is not high pixel, you're going to try to get as close as you possibly can to the number 5. And our answer will actually be the x value that stands with it. So this represents time in years, which is close to 12 years. It didn't ask me for months or anything. So again, here's the question. When does it occur? So if I take 2000 and add 12 years to it, it'll be in 2012. Alright, so here's another question. Let's read it. In 1981, the Australian humpback whale population was 350 and has increased at a rate of about 14% each year. Write a function to model population growth. Use a graph to predict when the population will reach 20,000. Alright, so let's break this down a little bit. First of all, let's start with the equation a of t equals a times 1 plus r raised to the t power. We know that small cap a stands for the starting amount, which happens to be 350. It has increased, and so I'm going to leave that 1 plus r, but I'm going to change that r to 0.14 and then pull those two together. 1 plus 0.14 is 1.14. I want to know when that reaches 20,000. So then remember that 20,000 represents the ending number. From here, I can divide both sides by 350. Again, I did those in colors so that you can see that that's something that I'm allowed to do. And I'm going to get approximately 57.14. Now here's where you're going to have to go to your calculator, put 1.14 raised to the x power in y1 and 57.14 in y2. In order for that 57.14 to show up, you're going to have to adjust your y max to about 60. And then you're going to have to pull out your x value to about 35. You can see from my answer that my answer is 31. So using your trace key, what you're looking for is how close can you get to 57 on that trace, and it's going to be close to 31 years. So that would answer the question, and the answer this time once again is 2012. I do believe we have one more to do here. We are looking at a decrease problem this time, and so we're going to start with that model, and we're going to put 1 minus r inside the parentheses. The initial amount, the amount that he bought the truck for, was $28,000, and we're going to subtract 9.5%, which is 0.095. And when you do that on your calculator, you're going to get 0.905. Now what we're trying to find out is, when does this truck's value equal $5,000? And again, you can knock off a few zeros there. Sometimes it's not best to divide by that 28 in this case because the number gets really small. So if I just leave it like this and put 5 into y1 and the right hand side into y2, then the graph looks a little bit like this. And what I'm looking for is, when does that graph, or when does the cursor fall below $5,000? And it looks like it's going to take about 17.3 years for the value to drop to $5,000. And I guess this is our last one. A motor scooter purchased for $1,000 depreciates at an annual rate of $15,000. Well, depreciate means decrease. So when I write out my template, I want to use the 1 minus r formula. I'm starting with $1,000. It decreases by 15%. I can simplify what's inside the parentheses by subtracting those two. And I want to know when it falls below $100. And again, you can divide by 1,000 on both sides, it's going to be such a small number. So just leave it 100 on the left and put that into Y1 and put the right hand side into Y2. You are going to have to adjust your window because you have a value that goes, or excuse me, a line that goes all the way up to 100 on the Y-axis. So change your Y max to something close to 105 maybe, and where it says X scale or Y scale, you want to kind of change that maybe to 50s or 20s or something, not 1, because it'll just make your Y-axis really dark. So with that being said, your answer should get close to 14.2 years using your trace key. Alright, so give these examples a shot. I want you to practice these on your calculator. If you're having issues or problems, let me know. But my expectation will be that you know what you're doing on your calculator. And I will see you in class.